Well, children, we have opened up 2 chapters, volumes and surface areas, and lines and angles. All right. Okay. So now look at this question. The radii of 2 right circular cylinders are in the ratio 2:3. Okay, so there are 2 right circular cylinders, and the ratio of the radii is 2:3, and their heights are in the ratio 5:4. Calculate the ratio of their curved surface areas. So see here, we'll say cylinder 1. So don't write anything now. Cylinder 1, cylinder 2. All right. Ratio of the radii 2:3. So let the radius of the first cylinder be 2x and the second cylinder be 3x. Let the height of the first cylinder be 5y and the second cylinder be 4y. You cannot use the same letter or the same variable x here. So for the first ratio 2:3, you have used x. Now for the other ratio 5:4, don't use x, use any other letter. Cylinder 1, cylinder 2, radius, ratios 2:3, so 2x, 3x. Heights, ratio 5:4, so 5y, 4y. Now somebody tell me the formula to find the CSA of a cylinder. Curved surface area of a cylinder. What's the formula? Okay, so 2 pi RH. 2 pi RH. So CSA of cylinder 1. Whenever we have to find a ratio, don't find the curved surface areas separately. Not only in this situation, whenever we have to find ratio, whenever we have to compare 2 things, don't find their actual values, directly find the ratio. Don't find their actual values, directly find the ratio. So CSA of cylinder 1 by CSA of cylinder 2 is equal to 2 pi RH is the formula. So 2 pi, you cannot write 2 pi RH for both. No, you cannot write 2 pi RH by 2 pi RH. You need to differentiate. Now 2 and pi are constants. R and H are the variables. So call the radius and the height of the first cylinder R1 and H1. The radius and the height of the second cylinder is R2 and H2. Now 2 gets cancelled, pi and pi gets cancelled. So this is equal to R1 into H1. So R1 is 2x into H1 is 5y by R2 into H2. That is the radius and the height of the second cylinder, 3x into 5y. Sorry, 3x into 4y. Sorry. So x and x gets cancelled, y and y gets cancelled. 2 ones are 2 twos are. So we have 5 by 6 or 5:6 is the ratio. 5:6 is the ratio. The required ratio is 5:6. See, you can also work without these assumptions. You can also directly do this. CSA of cylinder 1 without writing all this, CSA of cylinder 1 by CSA of cylinder 2 is equal to 2 pi R1H1 by 2 pi R2H2. So that's equal to 2 pi gets cancelled. R1 by R2 into H1 by H2. R1 by R2 into H1 by H2. Because that's what we have here. R1 by R2 into H1 by H2. That's what we have there. So what is R1 by R2? 2 by 3. Ratio of the radii into H1 by H2, 5 by 4. So you can work it like this without these assumptions also. So now 2 ones are, 2 twos are. So 5 by 6 is the required ratio. So the ratio of their curved surface areas is 5:6. And we have found the ratio without actually finding their curved surface areas. You don't have to find them because that's not the question. The question is not to find their curved surface areas. It's only to find the ratio of their curved surface areas, which we can find directly without finding the curved surface areas separately. Yeah. So I'm going to share these images on WhatsApp with you, children. You can complete this as homework. You have mostly tomorrow should be a holiday. Even otherwise, Sunday, Monday, holiday. So you have time to complete all this. So I'll share this image on WhatsApp later. You can complete this as a part of homework. Along with the questions you have to complete on polynomials. Now look at this one. The volume of a metallic cylindrical pipe is 748 centimeter cubed. Its length is 14 centimeters and its external radius is 9 centimeters. Find its thickness. Now we haven't seen the formula related to a cylinder whose wall is thick. The formula we have seen so far about a cylinder, that is the volume CSA and TSA. Volume CSA, TSA of a cylinder is of a cylinder whose wall is thin. The wall is thin, like if you make a cylinder using a paper cylinder. The wall of the cylinder is thin, right? So we have understood the formula to find the volume CSA, TSA of such a cylinder. Now here, this is a different situation. Now this one is called a hollow cylinder. A hollow cylinder. Now what is this hollow cylinder? A hollow cylinder is one in which the wall of the cylinder is thick. The wall of the cylinder is thick. I'll just get something for you. Just a minute. Yeah. So you can see this. Can you see something? What is that I'm showing, trying to show you all? I'm holding something. Yeah. Yeah. Correct. It's a sellotape roll. Now, when you buy a new one, this is cylindrical. The sellotape roll is cylindrical. And it's a hollow cylinder. See, it's open at both the ends. It's a hollow cylinder. A pipe will look like that. A pipe is open at both the ends. See, now don't mistake a pipe for a tap. You know, some of us, sometimes people refer to a tap as a pipe. We are not talking about that. We're not talking about a tap. We're not talking about a tap pipe. This is a cylindrical pipe used for plumbing activities. Cylindrical pipes used in plumbing activities. So now the sellotape is one of the good examples of a hollow cylinder. Now hollow because it's open at both the ends. It's open at both the ends. It's see-through. Okay, it's not a solid cylinder. It's a hollow cylinder because it's open at both the ends. And the wall of the cylinder is thick. Now clarify one thing for me, all of you. Can you see this object which I'm showing you clearly? Or it's not visible?
Yes, ma'am. No, ma'am, it's not visible.
It's not visible, no? 1 second. That's because I have a backdrop. 1 second. I'll just remove my backdrop. Yeah, now it should be visible. Yes?
Yes, ma'am.
Yeah. That's because I myself was not able to see it. That was the thing. I was not able to see it myself. I could see it not on the camera, but yeah. All right. So hollow cylinder, children, because it's open at both the ends. The wall is thick. The wall is thick. The wall of the cylinder is thick. Now, when you see like this, you can see two circular edges. You can see two circular edges. You can see one inner circle and one outer circle. You can see one inner circle and one outer circle. You pick, any object that looks like a hollow cylinder like this. You can see one inner circle and one outer circle. Inner circle, one inside circle, and one outside circle. There are two edges, one inner circle and one outer circle. That is why a hollow cylinder will have two radii, one inner radius and one outer radius. But the height is the same. The height is only one height. The height. The height is sometimes also called the thickness of the hollow cylinder. Because see here, when you hold something like this, you're showing the thickness, no? When you hold something like this, you're checking how thick it is. You're checking how thick it is. So sometimes the height of a hollow cylinder is also called the thickness of the cylinder. The thickness of the cylinder is the height of the hollow cylinder. Okay, so for a hollow cylinder, we need three values. Normally for a cylinder, we need only two values, radius and height. For a cylinder, normally we need only two values, radius and height. Now for this hollow cylinder, we need three values, one inner radius, one outer radius, and height or the thickness. So now let's understand the formula to find the volume of a hollow cylinder, the curved surface area of a hollow cylinder, and the total surface area of a hollow cylinder. Now let me do the CSA and TSA first. Now curved surface area. There are two curved surface areas here. One inner curved surface area, this inside, this one. One inner curved surface area, this one, and one outer curved surface area, this one. See, this is the cylinder. This is the curved surface area. This one is the curved surface area. This is the outer curved surface area. Outer circle, outer curved surface area. Inner circle, inner curved surface area. So inside also, inside. See, supposing you have to paint up this, if you have to paint the curved surface area, you will paint it on the outside here, the outer CSA. You will also have to paint it in the inside. because there is a CSA inside also, the curved surface area here. So the curved surface area of a hollow cylinder is the inner CSA plus the outer CSA. The inner CSA plus the outer CSA. We take both only if the wall is thick. If the wall is thin, then we take only the the outer one or the inner one. We will not take both. If the wall is thin, that is if there's only one radius. If the wall is very thin, there'll be only one radius because you can see only one circle. If the wall of the cylinder is very thin, like if it's made from paper, the wall is very thin, then there's only one circle you can see. So only one radius. Then if you have to find the CSA, we'll take only one. Either we'll take the inner, we'll find the inner CSA or the outer CSA. Both answer will be the same because there's only one radius, no? For inner CSA also you'll use that radius. Outer CSA also the same radius you'll use because it's the same. The value is the same. But here, when the wall is thick, you have to find the inner CSA with the inner radius and the outer CSA with the outer radius. Both are different values. Okay, so the total surface, the curved surface area of a hollow cylinder is equal to inner CSA plus the outer CSA. Okay, next, total surface area. Total surface area is like you want to paint up this all over. You want to paint up this all over. Everywhere you want to paint this. So what are the surfaces available to be painted? The inner CSA has to be painted, outer CSA. And when you see like this, you can see something which is called the circular ring. You can see something flat here because it's thick, you can see something flat here, which is called a circular ring. This one. This is called a circular ring. There's a flat portion here because the wall is thick, no? So there's something flat. You can paint up this portion also. This one. That's called a circular ring. So you can paint up this area and behind you have a similar portion. This flat thing, which is called a circular ring. So in all, a hollow cylinder has 4 surfaces to be painted. The inner curved surface area, the outer curved surface area, one cylindrical ring here, circular ring here, and another circular ring here. If you paint these 4 regions, the entire thing is painted. Supposing you paint this green, you paint the inner CSA, the outer CSA, the ring here and the ring here, then it will be green all over. If you paint it green, it will be green all over. You have painted this entirely. So for finding the curved surface area, it is the inner CSA plus the outer CSA. That's all. To find the total surface area, it is inner CSA, outer CSA, and the area of the 2 rings because they're identical. No, both are the same. Whatever area you get here, whatever area you have here, same area here also. So plus the area of the 2 rings. Okay. Now let's write the formula now. I've shared my screen, children. It's visible, right?
Yes, ma'am.
Yeah, good. So this is about a hollow cylinder. Please write down along with me. This one, formula alone. All right. Now, talking about the cross section of a hollow cylinder. Now you would have seen these metal plates, no? Metal, see, like between a nut and a bolt, between a nut and a bolt, a cylindrical, I'm sorry, a flat metal plate is placed so that it's tight. I don't have anything to show you now. It's called it's a flat plate, it's a flat metal plate. It'll be open here. It's like you have a big circle and you cut out a small circle from the middle. That one is a circular ring. A circular ring. How does a circular ring look like? It's like you have a circle, and from this circle you remove another circle of this with the same center but a smaller radius. You have a circle. From this circle you remove a circle with the same center but a smaller radius. So you cut off this. You cut this. So now it will be empty in the middle, right? Now this one only here there will be paper. Now paper is only here. Here it is a hole. This one is a circular ring. This one is a circular ring. So I'm talking about this metal ring, metal plate, which is placed between a nut and a bolt to tighten it, So, yeah. So now if you have many identical circular rings, you stack them, you place them one over the other, the solid formed as a hollow cylinder. The solid form. See, we have understood that when we have paper cutouts of squares, okay, you have many identical paper cutouts of squares of say side 6 centimeters. And if you stack them up to a height of 6 centimeters, the solid obtained is a cube of edge 6 centimeters. Now, if you have many, that's why we say the cross section of a cube is a square. Now, if you have many rectangles, paper cutouts of rectangles of some dimension, say 10 by 6, you place them one over the other, you stack them up to any height. The solid obtained is a cuboid. So the cross section of a cuboid is a rectangle. In the same sense, the cross section of a right circular cylinder is a circle. When you stack many circles of the same radius, the solid obtained is a right circular cylinder. In the same way, a hollow cylinder also has a uniform cross section. A hollow cylinder also has a uniform cross section. So how do you obtain this hollow cylinder? When you place many identical circular rings one over the other, when you stack them up to any height, the solid obtained is a hollow cylinder. So the cross section of a hollow cylinder is a circular ring. And a circular ring is like this, as I just showed you. One big circle. Say it's made of paper. Supposing this is made of paper. Now from this is the center of the circle. Say the radius of the circle is 5 centimeters. Now you cut a circle with the same center, but radius 3 centimeters. Radius 3 centimeters, you cut it off. So now it's open, it's empty in the middle here. Like this, if you have many pieces and you place them one over the other, the solid you get will be a hollow cylinder. So from this, the inner radius is 3, the outer radius is 5. And the height can be whatever is the height, say like height is equal to 6. Now, to understand the situation, I can tell you in 2 ways. We've already understood that volume is area of uniform cross section into height. Volume is area into height. And area means area of the uniform cross section into height. You can see the second one here. So area of the uniform cross section is a circular ring into height. Now you have seen in standard 8 as to how to find the area of this shaded region. How do you find the area of the shaded region? It is the area of the outer circle, pi capital R square, minus the area of the inner circle, pi small r square. This is the area of the shaded region or the area of the ring. The area of the ring or the area of the shaded region is area of the outer circle, pi capital R square, minus the area of the inner circle, pi small r square. This one is the area of the ring, the shaded region. So on taking pi common, you will get pi capital R square minus small r square. So this is the formula to find the area of a ring, a circular ring, or the shaded region here. So volume of a hollow cylinder is area of the uniform cross section into height. The area of the uniform cross section is pi r square minus r square into h, or it is pi h into capital R square minus small r square cubic units volume. This is one way of understanding volume of a hollow cylinder. There's yet another way to understand the formula. So a hollow cylinder is a solid which can be understood as from one solid cylinder, you're removing another cylinder of a smaller radius but the same height from the middle. You can just imagine that this is originally a solid cylinder. This one is originally a solid cylinder. Solid cylinder meaning there's material here also. There's material here also. It's a solid cylinder. Okay. So the volume of this solid cylinder is pi r square h. The volume of the solid cylinder is pi r square h. Now from this, you're removing, from this cylinder, you're removing a cylinder from the center of the same height but a smaller radius. You've removed that. So if you remove, volume reduces, no? So minus pi r square h. So this is the resultant volume. This is the volume of the hollow cylinder which I have now. So you can imagine the hollow cylinder as it was originally a solid cylinder. It was originally a solid cylinder. I'm not able to see the window. Yeah. So it was original, as if it was originally a solid cylinder. There was material here also. Okay. And from the solid cylinder, you have removed a cylinder from the middle of the same height, but a smaller radius. So if you remove a cylinder from the middle, the resultant solid is a hollow cylinder. So the volume of the original cylinder. Now that there are two cylinders, we have two radius. There are two cylinders, no? One original solid cylinder, and then from the middle, you're removing another cylinder. So there are two cylinders. So we'll have two radius, one capital radius, meaning one big radius and one small radius. So the volume of the solid big cylinder, that is the original cylinder, is pi r square h. And from this, what are you removing? You're removing another cylinder of the same height but a smaller radius from the middle. So pi r square h is removed. This difference will give you the volume of the hollow cylinder. So that's what I wrote here. External volume minus internal volume. Pi capital R square h minus pi small r square h. Pi h common. Capital R square minus small r square cubic units. So this is the formula to find the volume of a hollow cylinder. Coming to CSA and TSA. So the curved surface area is equal to curved surface area of a hollow cylinder. Curved surface area of a hollow cylinder is equal to inner curved surface area plus outer curved surface area, outer CSA. Curved surface area, the formula is 2 pi RH. If it is the inner CSA, it is 2 pi small rh. If it is the outer CSA, it will be 2 pi capital RH. H is H because the height is the same. Whether inside or outside, the height is the same. So 2 pi H is common, R plus R, square units. And the total surface area. The total surface area of a hollow cylinder is equal to inner CSA plus outer CSA plus area of two rings plus area of two rings. So inner CSA is 2 pi RH, outer CSA is 2 pi RH plus area of one ring is pi R square minus R square. Two rings, so 2 into pi R square minus R square. Area of one ring is pi R square minus R square. Two rings will be 2 into, double that. So you don't have to take out common and all that. I'll tell you now. Yeah, it's time already. We'll take a question and I'll tell you how you can solve it in the next class. So you can actually take out 2 pi common and give a different version of the formula, but I'll leave it here because we can find it separately. You can find the inner CSA, outer CSA, area of two rings separately, and then add everything to find the TSA. You don't have to remember that expression after taking 2 pi common. Not needed. That's not needed because I'm scared you will just mess up the formula and go wrong. So it's easier to remember like this. The TSA of a hollow cylinder, the total surface area will be the inner CSA plus the outer CSA plus the area of two rings. One ring is pi R square minus R square. Two rings, 2 into pi R square minus R square. The formula for CSA is 2 pi RH. This is only the formula for CSA, 2 pi RH. If it is the inner CSA, inner radius, so small r. Outer CSA, outer radius, capital R. Height is only one height. A hollow cylinder will not have two different heights. It has two different radii, but only one height, H. Share these slides. You can complete this. I'll just explain the answer to this question. Yeah. So here, the volume of a metallic cylindrical pipe. See, now how do you make out if it is a hollow cylinder or a cylinder where the wall is not thick? How do you make out? Whenever we have two radius, internal radius, external radius, whenever they mention two radius in the question about a cylinder, it is a hollow cylinder. It is a hollow cylinder. If they mentioned only one radius, then it's a cylinder, meaning it may be a solid cylinder or whatever. I'll take questions. I don't want to say anything now because I'll give you different questions, and using the situations I'll explain to you. Now for now you understand that when the question talks about two radius, then it is a hollow cylinder. That is, the wall of the cylinder is thick. It's a hollow cylinder. Now you can see here the volume of a metallic cylindrical pipe. When this pipe itself means it's a hollow cylinder actually. Is so much. Length meaning height. Length meaning the height of the cylinder is given. External radius is given. Find the thickness. Find the thickness. So again, in some questions, thickness will mean height. In some questions, thickness is actually the thickness of the wall. So again, it is situational. Now here, because the length is given, length means height. That means this thickness is the thickness of the wall. Length means height of the cylinder. So this thickness represents the thickness of the wall. And what is the thickness of the wall? The external radius minus the internal radius. The thickness of the wall. Okay, how do you find the thickness of the wall? Again, come back to the sellotape. How do you find the thickness of the wall? Whatever is the external radius, supposing the external radius, the radius from here to here is 10. That is capital R is 10. And the radius from here to here is 4. Small r is 4. What will be the thickness? What will be this thickness? From here to here it is 10. From here to here it is 4. So the thickness is 6. See, this is 4. The thickness is 6. So the outer radius is 10. So thickness is nothing but capital R minus small r. Outer radius minus inner radius is the thickness. Thickness is the outer radius minus the inner radius. Okay. So we are given the volume. So you write out the volume. Volume is 748. Now this is the formula to find the volume. Pi r square minus r square into h is equal to 748. Pi is 22 by 7. Capital R is given. External radius is 9. So capital R is 9 square minus internal radius we don't know. So r square into the height 14 is equal to 748. Now this one is 81 minus r square, and this is 7 ones are 7 twos are children. 7 ones are 7 twos are, they get cancelled, right? 7 ones are 7 twos are. So we have 81 minus r square is equal to 748. Now this 22 and 2 will come for division to the other side. 22 and 2 will come for division to the other side. And on simplifying this one, you get 17. On cancelling, you get 17. So 81 minus r square is equal to 17. And on working this, you get r square is 64. R is equal to square root of 64, which is 8. So the inner radius is 8. The outer radius is 9. The inner radius is 8. So that means the thickness is 9 minus 8, which is 1. The thickness of the pipe is 1 centimeter. All right, we'll be taking more similar situations, so things will become more clear, children. I'll share all these images on WhatsApp, the answers to these 2 questions, as well as the formulae. I'll just show you in case you're interested in taking a screenshot. No, I'll share the images right away, children. Let me not take your time now. All right, I'll share all this right away. All right, children, so that's it for today's session. Thank you so much. You may leave the call. Good night. Thank you, children. Good night.
Thank you.
Thank you. Yeah, good night, children. Thank you.
Thank you, ma'am.
Thank you. Good night.